You're going to cover a wish list smart contract. So wish list is the project this is going to serve as our class project. Then what we're going to cover is basically to walk through a wish list app smart contract. And like I said, this is a project that is going to serve as our demo project, our class demo project. So we're going to provide it smart contract. Then later, after covering the front end, we'll see how we can give it some front end. Now, here's our project. Let me just bring in our famous folder, scripts folder. Great. So there we go. Now inside here, we have our usual uh, script files. So we have the settings that you're going to, let's give these C4 Sankore, what we just created while you are starting or at the beginning of some of our session. So the sub account you're going to name this is wish list. So that is going to serve as our sub account wallet address, wishlist.c4 Sankore. Yes. Our build is great, but we need the resource folder, so I'll just add that as well for us to avoid unnecessary bugs. Then over here, we will not delete the account because it doesn't exist. However, we'll go ahead and create the sub account, giving it an initial balance of 20 MIA tokens. Then we'll finally deploy our smart contract, but then you're gonna have to change this to wish list so that whatever is going to be generated will be well captured within this path. So those are the changes I've just made in the file. Then under the call script, we're going to have some other commands we're going to execute. However, our signer ID is going to remain what we've been using so far. So that is it. We'll be updating this as we proceed. Great. Over here, yeah, I think that is basically it. I don't know if you guys are able to see this, but let me just try and increase the font. I hope that is quite better. Great. Then I'll just go ahead and close all the files for now. Good. So let me head to my source folder of our contract workspace. Inside here we have 3 files that we're using or making use in our code. And these files are basically holding some source code that we're going to utilize. So let me just begin with the smallest unit. So in this case, the vehicle.rs file. Our vehicle.rs file or module, so in this case, I will refer to it as a module, is basically containing a declaration of this one is basically containing a declaration of a vehicle object. Okay. So in our maybe if I can just give us a brief description of what our wish list project is going to do. Okay, just an overview. Let's just have an overview of what the project is intended to do. Now, in our project, we expect users, in this case, those who are going to utilize or interact with our system. First of all, they're going to have to log in. Then after logging in, they're going to have this functionality to be able to update car records or create car records they would wish to buy later in the future. Okay, so it's as simple as that. So they log into our system, and in the account, they're able to provide key information that we want to capture. So like the car name, model of the car, the mileage, the year, the price, and all that. Then after we capture this information, we send it to our smart contract. And within our smart contract, we're going to store this car record in the user's wish list. So next time the user comes to our app and logs in, we are able to display this information to them. If the car they added they no longer need it in their list, so they basically want to remove it from their wish list, then you're going to as well provide that functionality in that they're able to just click on a button and delete or remove the car from the wish list. Again, if you're coming from the Web2 background, this is what we refer to as CRUD operations. So the user is able to create a car object. A user is able to read the car information that they just added. A user is able to update. Okay, in our system, we want to bring in the update feature, but you can as well do that. Okay, you can basically say, hey, provide an update functionality where the user can key in the details of the car, and they're basically able to do what? To make the update. So that is very possible. Then the last, the delete, our user is also going to be able to remove the car object or the car information from their wish list. So that is an overview of what our system is basically doing. Now, in this file, we have the vehicle structure. Vehicle structure is basically a structure that is going to hold the vehicle information. So this is the smallest unit in our system. And a vehicle is expected to have an image, the name, model, mileage, year, and price. Okay, so that is basically what's happening in this file, guys. Nothing more. Great. Then after that, let's head on to the user's to the user.rs file or the user module. In our user module or the user.rs file, we have the user object or the user structure right here. So you realize that in our user structure, we basically have one property, and that is the wish list. And within our wish list, now I'm not covering this importation and all that because I believe up to now we should be familiar with that. So I'm just going ahead and covering the main points within our file. So within the user structure, we have one property, and that is the wish list. And the wish list is basically the usual vector collection from Rust. Remove that. The usual vector collection from Rust, and that is vec. So this vector is basically going to contain items of type vehicle. Okay, and we saw that structure earlier. Then we give its default implementation. This is basically going to initialize an empty wish list. Okay. Then right here in our where we're implementing the user structure, we have the new user function. And this new user function is basically going to help us initialize a new user object. Okay. So by initializing a new user object, we're basically going to give it an empty vector, or in that case, a growable array. Okay. Then after initialization, we have the structure methods following. And I think we have 3 of them. Yes, we have the remove, the show, and the add. So we're also going to go through this. The add function basically adds a car object to the vehicle's vector. Okay, so to add a vehicle object, to add a car object into a wish list, we'll need these parameters. So just provide us with the image URL of the car, the name of the car, the model of the car, the mileage, the year, and the price. So that is what is coming in. If I can remove that, that is what is coming in our function signature as parameters. Then in line 38, we are creating a new vehicle object by doing vehicle and invoking the new function. Now again, maybe if I can just head back on the vehicles, we are having this new function over here, which is basically initializing or creating a vehicle object using the parameters passed. Okay, so let's down back to the user. So that is basically what's happening in line 38. We're creating a new vehicle object, passing in the parameters we've just accepted from the add function. Okay, then once we have the vehicle object in place, it means we now have something we can push to our wish list, right? And that is basically what we are doing in line 39. So we are doing self.wishlist, which is now this vector is not near SDK vector that we talked about. You realize it's vec, not vector. Okay, So this is coming from Rust, out of the box from Rust. That is what we covered actually while we were doing Rust. So in our add function, we have self.wishlist, then we are pushing the vehicle object. Okay, that is basically what's happening right there. Then this function doesn't return any value, so that is void. Let's move on to the show function. The show function retrieves car objects from the vehicle's vector. Again, to show, like I said, our vector could be containing several items. So instead of, retrieving all the items, although these will still be uploaded in computer memory, so it really may not be the efficient way of going about this. But as developers, you can think of the way you can go about this. In fact, you can use the vector object or the vector collection from the NIA SDK library. But for now, since this is just a demo, that is why I opted that we just go with the standard vector out of Rust collection. So right here, we are doing self.wishlist, then getting an iterator out of the vector. Then we skip to the index. We want to start reading this information. So we just pass that as a parameter and as this type. Then we take the number of elements we need. Okay, so like I think I covered this while we were doing storage, where we were paginating our items that we were retrieving from the vector collection. And there's somewhere I was almost using this particular statement, but then I said we'd look at it sometimes later. So we skip to the index we want to start reading. This is the page. Then we take the number of items we've specified. So these are the number of items we want returned. Could be 5, 10, or all that. Then we clone. By cloning, it means we are basically getting a copy of that of the elements, and we collect them. So by collecting, this is basically going to create another vector out of the items we've collected and store them in this result variable. So that is basically what we are returning in line 47, returning a vector of vehicles. So it means if our wish list is going to contain 100 vehicle objects, then you can basically specify that, hey, start retrieving from index 70 and take the first 5. So that it will basically give us 5 vehicle objects from index 70 of our wish list vector. Great. That is basically how we go about that. Then to remove an object from our list, in this case our wish list, we're going to use the remove function or the remove method. This one is going to delete a car object from the vehicles vector. And our remove method is accepting one parameter, that is, or we expect the user to provide this one parameter, that is the index parameter. And this is basically going to specify the index where the object is located, or the vehicle object is located within our wish list vector. So given that index, we are able to remove that exact vehicle object. So how do we do that? In line 54, we first of all get the length of our wish list as a 64 unsigned 64-bit unsigned integer. After getting the length or the size of our wish list, in line 55, we first of all assert or ascertain that that size is greater than 0. So again, this is just to remove unnecessary errors. You could have passed an index, but then your array doesn't contain anything, so it will raise some error. So this is what is going to help us do that. So first of all, assert that the size is greater than 0 and the index is less than the size of our array. Otherwise, we'll simply return the message wishlist empty. Then in line 55, we'll panic with the message wishlist empty. Then in line 56, we are basically, we are actually removing the object we've specified. So in that case, if the assertion is if the assertion went through, or if the assertion was true, then we proceed to line 56. If the assertion was false, then our program will basically panic in line 55. So it will never go to line 56. But if things went well, then it will head on to line 56, then do or perform wishlist.remove. Then we basically specify the index of the object we want to remove. And that is basically it. That is what is basically happening in our user object. So in our user structure. Now I want us to head on to our lib.rs file and see how we are making use of our user structure. So again, right here, I'm just bringing the two in that line. Then I think you're familiar with the rest of the line. So we have our wish list structure in our main file. So in our main file, we are having the wish list structure, okay? And our wish list structure is where we're going to avail functions that can be invoked within our smart contract. So within our wish list structure, we only have one property, that is the user's property. And this one is a collection, lookup map collection, that is basically going to store a user object against a user wallet address. Okay. So in line 29, we are giving the default initialization to our users collection. And that is how we go about that. And in line, yes. So from line 35, we're basically implementing the methods that now will sort of help us interact with our smart contract. Okay, so we are implementing our wish list methods. And the very first, I don't know if I can, let me just minimize the functions for now. We can walk through them as we proceed. So let's first of all talk about the add car method. Now, this method is basically given the parameters that we need, or the parameters we expect the user to pass in, and that is basically what you can see: image, name, model, mileage, year, and price. We're going to be able to add that particular car information to the user's wish list. Okay. Now, the very first thing we're going to do in our add function is get the user account ID, because this is the ID or the key we're going to need to either store the user object or persist the user object on blockchain, or retrieve that user object from blockchain. Okay, so that is what you're going to get first. The second thing we're going to get is the deposit. So this is the amount the user is going to attach to this particular transaction, because you realize that the function is payable. Sorry, right here. This is the mark I wanted to highlight. Line 39, the function is payable. So we're going to expect the user to attach some near tokens while invoking this particular transaction. And again, we covered this in storage. So in line 48, we are getting the initial storage space. So this is the space before the user data was added to the blockchain. Okay. Then in line 51, we are basically checking. Now, guys, I really want you to be keen on this. So the very first thing we are doing before adding that kind of information is checking if the user object exists in our users collection. In which case, if they exist, then we will basically get the user object as captured in line 51. So this user object, then we invoke user.add function, passing in the parameters we captured from our add car method up here. So these are parameters. That is basically what we are passing down here as arguments to this add function. So this add function is invoked on the user object that was retrieved from our users collection or our users lookup map. Then after making this change, we need to update our user object on blockchain by doing self.users, so our users collection, then insert our user object under the user's wallet address. Then after doing that, we basically pay for storage. So I covered this function in our storage class previously. So what it does here is basically the same as what we saw previously. We are passing in the initial storage and the deposit, then it will compute and settle the storage cost needed, the user is needed to pay if they attached enough near tokens. Okay. Now, if the user that was not found within our users collection, so in this case, the user trying to add the car information is interacting with our system for the first time. It means they don't have account with us. So they are doing this for the first time. In that case, the information will not be found within our users collection. And so we need to create a new or create them a new user object that we are now going to persist on blockchain. So else, so that comes under the else block. So if the user was not found within our collection, we're going to initialize a new user object by invoking our new user function of our user structure. Maybe if I can take us again over there. So this is the function right here. So it's basically going to create a new user object, but with an empty wish list. Okay. Then back to our lib. After initializing the new, sorry. Great. So after initializing a user object, we are now going to use this newly created user object and invoke the add function of that user object. Then we're basically going to pass these parameters as arguments to the add function. And this is basically going to add this particular car record in the user's wish list. Then from there, we persist, okay, down here, we persist this object on blockchain by storing the user object that we just created under the user's wallet address. So again, we find the wallet address we found that by invoking the predecessor account ID up here in line 42. Okay. Then let's head back down here. So after storing that user object on blockchain, again, we'll have to do what? Settle storage cost. So we process the payment, and if they attached excess, we'll basically refund them their change or the excess. Great. Now, that is basically it with our add car function of our wishlist smart contract. I'll just minimize it and move on to the next function, which is read wishlist. So read wishlist is basically given whoever is going to sign this particular transaction, right? We're basically going to be able to read their wish list. So basically get the data they need and display it back to them or return it back to them. So the very first thing we're going to do is basically get the user account ID as captured in line 93. Then in line 96, we check if the user exists within our users collection, because it's possible for a wallet address that has not added any car record within our users collection to invoke this function. And so if you really don't capture this well within your code, guys, you're going to face some errors, or your smart contract is likely to break at some point when such transactions are made. So it's always a good practice for you to first of all check if actually the user exists within your collections before you do any operation with them. So that is what we are doing right here. So if the user that is signing this particular transaction exists within our users collection, we'll basically get the user object from our collection. So in this case, we are retrieving this user object from our collection. You realize it is of type user. Then using that object that already exists on blockchain, will get a list of car objects in the user's wish list. And how do we do that? We invoke the show method of the user's structure. So right here, so we looked at this function, the add function. Then the function we are now invoking is this, the show function. And we've also talked about that. So back here, we are basically invoking the show function over there, of our user object, passing the start and the limit. Now, if you're really keen on the read wish list, that is line 91, the read wish list function signature, you realize that the user is specifying the start index and the limit. Okay, so this information, like I said previously, is going to help us paginate our response so that we don't return everything or all the items at a go. Then down here, we basically pass those as parameters to our show function or show method of the user object. Then after getting the records we need, we store that in our vehicles variable and return the vehicles. Now the vehicles variable is holding a vector that is basically going to hold items of these data type, the vehicles data type. Then after that, we're going to return the vehicles enclosed in this sum enumeration object. Now, if you're going to have, so this is basically going to return an option meaning if we found something, we'll return the item. If we didn't find anything, we return an empty, or we return null, okay? So that is basically the implementation of or what we're trying to achieve at this point, okay? So in the event that nothing was found, so the user never existed within our user's collection, then we'll basically return an empty vector. In this case, an empty array, okay? Just like that, right? And that is basically it about the read wish list, as short as that, basically retrieving a paginated user car wish list. Then away from that, let's go ahead and cover the delete car method. It's quite a bunch of code. We're going to understand what's happening. So the very first thing you need to provide us, as captured in the delete car method signature, is the ID of the actual car object you want to delete from your wish list. Okay, that is what is basically captured in the delete car function signature. So in line 112, we first of all get the user's account ID. Then in line 116, we are getting the initial storage. Now, maybe just to reiterate, while deleting a data or while deleting data in our smart contract, it means that some storage space is going to be done. What is going to be released? You're basically going to release some space. Okay. So after the delete operation is successful, then it is wise, or it is kind of us, to refund the user the amount of tokens that was released by releasing or deleting some data. Because like I said, while you're storing data on the NEAR protocol blockchain, some NEAR tokens are going to be locked out of the wallet address of that particular smart contract to cater for the storage cost. However, if you release the space, in that case, if you remove the data you stored, then that NEAR token is going to be unlocked. Okay. So it is basically going to be added to the, or released or credited to the wallet address of that particular smart contract. Now, in this case, instead of us, taking advantage of that unlocked NEAR token, because the users paid for it while they were storing that data, right? So it only makes sense if we are able to refund them back that unlocked token. Okay, so that is basically what we're going to achieve in our delete car function. So in line 115, we first of all capture the initial storage. Then in line 118, yes, in line 118, we first of all check if the user again exists in our users collection by passing in the signer address or users account ID. So if they exist, then that is the only time we go ahead and delete or remove car. Okay. So in line 120, we first of all, using the ID they've passed in, remove the car object they've specified. So we do, using the user object we found in our users collection, we simply invoke the remove method, passing it or specifying the index, in this case ID. So that is basically going to remove the car or the vehicle object. Then if we head on back to the users file, the remove, this was returning the vehicle object. So the remove function, as we covered, I think, while doing storage, it removes and returns the element at the position or the index we've specified. So we specified that we're going to remove the vehicle at index ID. It will go ahead and remove that object, then return it to us. So that is basically what we are capturing in these. That is what we are capturing in this removed vehicle variable. I hope that is clear. Then after removing the vehicle, we need to update the user or the user object on blockchain or in our users collection. If we don't do that, then our user object will still reflect the initial state. So also take good note of this. If you don't do this, then you may not be able to see the changes as you expected. So since we've removed a car from this user object, we have to update or store this user object again. So that's why you see that we're doing users self.users.insert the user object under the signer wallet address. Then after the object is successfully removed, after the object was successfully removed, then we want to do what? We want to refund the storage cost back to the user because they initially paid while storing that data. So it's only kind of us if we can refund them back their money when they delete it. All right. So that is what is happening in line 126. Again, we're going to look at this function extensively. So we're passing in the initial cost as was captured up here in line 115. That is what we are basically passing in to the refund storage cost. Then after that, we return the removed vehicle again as an option down there. But if the user was not found, you remember all that operation was is going to be executed if the user is going to be found within our users collection, right? So in the event that the user was not found within our users collection, then we'll basically do what? Return none. So in this case, this will return null. Okay, so that's why we have the return type as an option of the vehicle object. So by option, I mean it can be there or it may or may not be available. Okay. So yeah, that is it about the delete function. I covered the pay for storage in during our storage session and the return excess function as well. So I'll just head on to our refund storage cost function and really have a look at what is going on there. So again, we are able to get our heads around it. So over here, the very first thing we are doing is getting the account, the user account ID again, though we are not making use of it, but I'll see why that is the case. We could be making, yeah. we're actually not making use of it, so I can just remove this. I'll tell us why. Now, the very first thing we're doing is getting the current storage cost. Okay, so this is going to be the storage cost after deleting data. So that's why I've named data current storage. And we do that using the storage usage function that we covered as well earlier. Then we compute the storage space released. And how do we do that? Now, since we are removing data, then it means that the initial storage value should be greater than the current storage value because we've removed, we've released some space. So if we had 50, uh, if we had 50 GB of data occupying our storage, then we remove or we delete 1 GB of data, then it means our current storage is storage space is going to be 49, right? So if you wanted to know the storage released, then you would take the initial storage, which would be 50 GB, minus the current storage, which is 49 GB. And in that case, you're going to get 1 GB storage space released. So that is what is going on in line 183. Then in line 186, we are getting the storage cost in bytes. Okay, so this is going to be the storage cost per byte. And again, we get that information using the ENV module, invoking the storage byte cost function. Then after that, in line 189 over here, we are computing the total refundable storage cost. Total refundable storage cost is the total amount we need to refund back to the user. Okay, so we have the storage released. In this case, with the example I've just given us, we have 1 GB of storage released. All right. Then over here we get the storage unit price. So for us to get the total cost or the total tokens we need to refund the user, then we're going to take storage released multiplied by storage unit price. Okay, so that is what we are doing in line 189. We do storage unit price, then we just this function checked mul is basically helping us to safely do the multiplication. Okay, and again, this happens on the 128-bit unsigned integers, or the 128-bit integers. So if we invoke the checked MUL or checked multiplication, then we pass in our storage released. Okay, then we are basically converting our storage released into a U128 integer type for us to be able to do the multiplication. So the result of that particular multiplication is going to be stored inside these variable refundable storage cost, as I've just highlighted. Then inside our if block, we're going to basically invoke our return excess tokens, passing in the refundable storage cost as an argument. So this is basically the amount of tokens that is going to be refunded to the user or going to be credited to the user's wallet address. Then if this raised an error, so if there was an error in the multiplication, then our program is basically going to panic. And by panicking, it is going to roll back what? All the transactions that took place previously. Okay, so that is basically it about the refund storage cost method of our class. I'll not touch on our tests for now, but I'm going to avail this. You'll be able to see how things are unraveling. Maybe just to touch on something, I think I wanted to mention this while I was starting the elaboration, that if you're keen on our get context function in our, I think it was our greet, yeah, it was our greet project, the blockchain project that we just began with. it's looking a bit different with that. Okay, so this one is a bit simplified. I think this is a good improvement. So we have VM context builder module that we are again importing into this test module. Then we just invoke the new function of that. Then we specify our assign account ID if it is a view. Then we pass in our attached deposit. So these are methods. So they just need us to pass in values to them. Then from there we build. So if we build, this is going to generate a VM context or give us a VM context value, and that is basically what we are returning. So that is what I've been able to use there, and the tests are all illustrated as you can see. So maybe if I can be able to run the test first before we even proceed and do cargo test. If everything is well captured, then these should pass. Let's just have a look. Yeah, so everything is passing. So once you have this from your end, guys, these should be able to execute successfully. Great. Now, let's see. I want us to now, since you've gone through the code, we have a grasp of what's going on. So we have the general view of what our application is going to do, and we've also gone through the nitty-gritties of the smart contract and seen how everything is basically put in place. So I want us to go ahead and test this particular smart contract and see what is how these events are unraveling. The very first thing I'm going to do is build it. So first of all, I'm going to grant our script files permission to execute. Since I'm Linux, that is how I go about it. And that was successful. Then I simply need to do or to execute our build script. I think this should be good. So let's go ahead and see what this is going to give us. It should build a smart contract and generate a WebAssembly bytecode that will be able to now deploy on the Media Protocol blockchain. Awesome. So that was successful. I just clear that out. Then the second thing we're going to do is do what? Deploy the smart contract, right? So let's have this deploy to our, I hope we configured everything. So you have everything in place, great. So let's just go ahead and deploy this, execute our deploy script. Let's hope that is going to work well again. Okay, I think that was successful, great. It's telling me to upgrade my near CLI. I'll do that later. So for now, I just want us to, let me clear that as well. I want us to head on to our call script and bring in our commands or put our commands in place. So I've just brought them in. Let me exit this for now as you walk through our commands. Great. So let me comment this out for now. Great. So we're going to have an add car to wishlist command, show wishlist content command, remove car from wishlist command. Then I'll just remove this because this is irrelevant for us. So basically the three commands, okay? So let's go ahead and start with the first one. So we're going to add car to our wish list. In this case, we're going to sign this particular transaction using our specified signer wallet address. That way, great. So I just did near call because again, we are making use, or we need to sign this particular transaction. So we do near call, passing in the sub account where our smart contract was deployed. The name of the function is add car. Then our add car function accepts the following parameters. The first one is image, and here is the value. So it's basically a link to an image. The name of the car, so in this case Toyota. The model of the car, in this case RAV4. The mileage, we are keying in the mileage as an integer, so 1000. Year as a string, 2022, and the price, okay, is also going as an integer. So that is basically how we provide the parameters to our add car function. Then we sign this particular transaction using the account ID flag, passing in the value as our signer. So we're getting this from our signer variable in line 3 up here. Then, so remember, for us to be able to add car, we need to fund the storage, or we need to settle the storage cost. So that's why we are attaching 1 year token using our amount flag. Okay, so that is how we do it. Again, I'll be showing us how we go about this when it comes to web interface. So basically how you can attach the token when you're doing this from your web interface. Now, I just want us to go ahead and try this out. Let's go ahead and call or execute our call script and see what this is going to give us. So remember, our function was not returning any value. It means if everything goes well, it should give us an empty string. And great, that is exactly what just happened over there. It responded with an empty string. So it means all the information was successfully captured in our wish list, or we successfully added the car record in our wish list. So I'll just comment that out because we are done with that. Then we now want to see how we can read this information from our wish list, the information that we just added. Okay, so that takes me to line 12. So this is the command we're going to execute to basically view our wish list. We do near call, pass in the account ID where we deployed our smart contract. The function in this case we're going to execute is read wish list, and the parameters, maybe if I can just take us back to our source code and show us these. So our read wish list method requires the start and the limit parameters. So those are what we are again bringing in. So we're going to start from index 0, and the limit is the first 10 objects, the first 10 car objects or cars, okay, within our wish list. And again, we're going to sign this particular transaction, yes. And to do that, we use the account ID flag. Then we just make use of our signer wallet address availed in our signer variable. And yes, that is basically what we need for us to be able to invoke that command. So I'll just go ahead and clear my terminal and execute our call script again. This time around, it should display an array to us containing our car, or the cars we have within our list. Unfortunately, this is raising an error. Let me see what that. Oh, it's not an error. Yes, it's not an error. It's actually the object. Let me just expand this because it was looking to me like an error. But here's the result. So we are having an array of our car objects. So at this point, we only have one object within our car, or within our wish list, sorry. We just have one car. So that's why we have one car object, or one vehicle object, in this case, specifying the image, that is the link, the name of the car we added. And if you're keen, all the information that has been captured here is exactly what you provided while invoking the what? The add car command in line 9 up here. All this information, okay? So that is exactly how we invoke or go about, we can minimize this a bit, yes. That is basically how we go about reading our wish list. Then let's now try and remove some data, right? Let's try and remove some car information or car items from our wish list. How do we go about that? In line 15, here's how we go about it. Let me just bring in our sign a variable down here. Great. So we are doing near call, and we are calling a smart contract in this account ID. The function we want to invoke this time around is delete car, and our delete car method accepts one parameter, that is ID, as captured in the function's signature. And back to our command, we capture the ID parameter, passing in the ID of the index of the car object we want to delete. Now, like I said, apparently we only have one. We only have one car object in our wish list, right? Just one car within our wish list. So if we specify one, these shouldn't delete. Okay, or it should. Let me see if it is going to panic or raise an error. If we capture that as well. So, okay, so at this point, we are basically going ahead and removing it from our wish list. So, yeah, these should panic. So these should panic. Let's go ahead and try and run it as it is for us to be able to see the error. We'll just clear that for now. Then execute the call script again. So this time around, we've specified an index that is beyond the bound or out of bound. So you realize it panics and it says, hey, the smart contract panicked with this message. So it panicked at wish list empty. This is basically the message that we specified in our, where is that? If I can get our remove, yeah, our remove. So wish list empty. Okay, so this is the message that we basically specified at that point. Though we can update this to something else. We can call this invalid car ID. Yeah, I think that makes sense. Let's just change that to that. Great. So if you provide an index out of range, then it is going to raise this error. But this time around, I want us to provide something that's within range. So we just have one car object at index 0. So that is why I'll just change that from 1 to 0. Now, executing this again, it now should be successful, and it should basically respond with a car object that is going to be removed from our wish list. And that is exactly what happened right here, guys. So you realize that this one is not wrapped in an array this time around, but it is just the object. Okay, so this is the object that was basically removed from our wish list, and it is basically the object that we added earlier, right? So that is basically it. Now, if I try to read or show or view my wish list again with a second command down, sorry, the middle, this time around I should be able to get an empty vector. So these should basically give me an empty vector. Okay, so an empty array as captured in our terminal right there. So that is basically what's happening. That is basically how we go about that. Now, I wanted us, I think, yeah, here is our remove function. And we have an Explorer, an Explorer link right here. I'll just open this up in a browser. Or, okay, let me just copy the link. Then I'm going to share my browser so that we see what really happened. So this is basically, like I said, it captured the transaction. And so it is basically showing us how everything was executed on the blockchain. So we use the Explorer. I hope you can see the screen. So we had polotieno.testnet sign the transaction. The receiver of this transaction in this case was wishlist.c4-sankore.testnet. That is our smart contract. And the operation succeeded. Okay. We attached 30 teragas, but then we only used 6 teragas. We didn't attach any deposit, and the transaction fee was that. It also gives you the time that when it was created and the hash of all that. So here the arguments we passed, the ID was 0, okay. And in our receipt, that is also captured. Here are the results that was basically returned to us. So everything is everything is basically displayed to you as they unraveled, okay. I wanted us to see where the tokens are actually being refunded back to us. Yeah, so right here. So this, after releasing space, that is, after we deleted the data, here is the amount that was basically done what? Transferred to us. So we were transferred 0.00001 near tokens to our wallet address, in this case, to paul.otieno.testnet, okay? So I think that is basically that. Okay, let me see. Yeah, I think that is basically it. So that is how you can basically have a look, or make this, where blockchain brings in transparency. If you're claiming that, hey, you did this within my smart contract, we need a proof. You can simply share what? Share the link, the Explorer link, or you can capture the block height or the block index, as we saw, guys, while you are going through the ENV module. So if you go back to that session, there's a way we were getting index or the block ID, in this case, the block height. So you can take that information or that value and paste it here and basically do a search for it. Then it is going to display all this information to you. So this is very much possible. That is where transparency kicks in blockchain.